having made a test to see if I can machine the sides of a watch case like this, I have acquired a movement, ETA 900 001, 13 mil across, 15.55 mil up, with a battery movement and hand stack should come out as 3.45 millimeters thick. So I am hoping for a watch case and case back totaling under 5.5 millimeters. The next step is to produce a movement ring to hold on to the movement and attach into the case. I've previously made one for an Omega mechanical movement. With this movement, it has a arcing top and bottom around the center, so an entirely turned part could be produced. With this one, with its flat top and bottom, I will have to turn the required outside features and mill a rectangle inside of the right size to grip onto the movement. That Omega ring was for this watch that I've been working on, making the case, dial, still have to make the hands, those are the original hands, made the crown and the case back, and testing by wearing. I've been very much enjoying wearing it. For this though, next step is movement ring. So I set up a Morse taper part in the headstock and indicated in the top slide to that, so that I can turn a taper onto the bottom of my brass stock that I'll make the part out of. It's not the long term the most efficient use of stock, but the quickest way for me to set up to mill inside a round part, I thought, was to be able to machine a taper that it would fit inside the rotary table. I do quite like turning tapers using a MT2 to 3 sleeve to gauge when I am down to size, facing it, and I'll drill and tap to be able to hold it with a drawbar into the rotary table. Fun machining brass as well as opposed to stainless for a change. Parting that off, because it's in the rotary table, I made a cut, spun it 180 degrees, made a cut in the hope that I would be perfectly centered. I think perhaps that's not necessary, and I could just make a one constant cut all the way around, and then milling out the slot which allows the movement ring to expand and contract and allow access for the stem and crown. There's more turning required at this stage, but here, just because I'm testing it, I'll turn it into a simple disc. The finished part, I am very pleased to say, fits rather well, with a good amount of grip upon the movement. The first major thing that I would like to change though is use a larger milling cutter, so there'll be a larger radius in the corners, leaving more material behind, as this does get quite thin, and I fear, although I want the part to spring open and expand onto the movement and then grip it, I don't want any chance of this bending, and some of this underside does get machined away to fit down into the movement. So with a larger cutter, I'm confident that now that I should be able to make this work. And so the next adventure is translating this learning and the numbers into the drawings for the case, and that's my next step.